Hey dude, I'll give you a real basic demonstration of what I'm talking about. Now this is in the studio, so I'm not using any of my mathematical labs. I'll just give it'll give a real basic understanding. Now, when you're testing for intermodulation distortion in circuits and stuff, what you're supposed to do is test at 60 hertz and about 7K. So what the problem with intermodulation distortion isn't so much that what's happening with it. You'll see that, well, what I'll try to show you is the issue we have in the music community, because in the electronics community I can deal with it. I can deal with it with capacitors, I can deal with it with resistors, transformers, there's all kinds of ways to deal with it. Plus, normally you're just dealing with one signal going through it at so many gigahertz or so many hertz, or you've got wideband from other applications, but normally it's not that big a deal. But with what we're doing, it's a huge deal. I mean, it's a mess. And in the audio industry, as far as what we do, that it's a problem. And here's the problem is okay, here's one at 60 hertz, right? Okay, so you've got one at 60 hertz, and this is just a sine wave. So imagine this is a sine wave, but try to imagine that you're dealing with a symphony, and you've got 80 different instruments going on, and then you're adding saturation, or you're adding the mix FX or some other kind of console shaper, or God knows what you're doing. You added some dither to it, or whatever you did to it. Anything that's making the circuit nonlinear, because that's what it works out to. It's causing a nonlinearity, which causes the intermodulation distortion, which are two separate things. But the problem is whenever one happens, it causes the other with what we do, because whenever you're getting a nonlinearity or causing a nonlinearity with any type of distortion, that it's going to cause intermodulation distortion if you've got more than one signal. So any song you make, it's going to have more than one sine wave in it no matter what you do, right? I mean, even a C chord has so many different harmonic characteristics to it that, I mean, there's no way around it. So, but anyway, here's the problem. Here's just a Sawtooth Distortion. Now you just crank it up, you can see where the level's at. It's not much, and you can see all the harmonics it's causing, right? Well, I mean, that's just one sine wave. So now the problem is, and the same thing if you're going like, if you're testing it and you're going to use the upper frequency and you do the same thing, you see where the level is at is a comparison to down here. This is the way you're supposed to test for it. But you watch what happens. Now you see what's going on there, that it's doing the same thing. And the problem is with the distortion is that the other frequencies are louder than the frequency you want to hear. Now your ear might not hear that, but it comes out that way. To try to explain that the way your ear hears it, that's a really in-depth conversation about equal loudness curves, Fletcher-Munson curves, and all kinds of concepts as far as how your ear perceives sounds, and I don't want to get into all that. I could talk to you about that for the next 2 hours, and you might understand all of it, or you might already understand it, so, you know. But anyway, the problem is when you're doing that and you've got one or the other, when you put them together and you start causing this, and you've got any type of nonlinearity you're introducing into the signal, any type of distortion, any type of saturation, almost any type of effect, even reverb, which all it does is even the nicest reverb you got takes and duplicates all the floor noise and any other type of distortion you have and amplifies it by magnitudes. So it causes the whole problem to even get worse and worse and worse, which is why a lot of audio engineers, or quote-unquote audio engineers, have been mixing, that they'll start steering clear of processing because they may not realize it, but what's happening, it's multiplying all the crap by magnitudes every time they put a processor on there, most of the time. Does that make sense? And causing nonlinearities, intermodulation distortion on top of it. So what happens here, you start putting on this distortion, any type of nonlinearity from your processors. Look at all the sideband distortion happening up here in the upper frequencies. It's a mess. And the problem is this. Check this out. You crank it up a lot, and you've got one track that's got a lot. Well, it's going to get fed into all the other ones. You get crossbleed. You might not see it, but in the summing it happens. Even if your digital realm says it's not, it's still happening. And that's the problem. So the problem is here you come to like this, and if you kick off like the lower frequency, and you can still see it up there, you kick the higher one, the lower one back on, kick off the lower one, watch what happens to the lower frequency. Not much. Actually, the higher intermodulation distortion is canceling out a whole bunch of this stuff. Does that make sense? And lowering it. So that's a plus. But it's also affecting the tone. It has to be consideration. So if you're not taking that consideration, you're not even understanding what's happening in your mix. And when you turn one knob 1 degree, what just happened? Does that make sense? So you're trying to hear it with your ear, but you don't really know what's going on there, which too much of that means you really have no idea what happened in the mix. So then the problem is you kick it back on, it's not doing that to the lower band down here, correct? And then on top of it, what's happening, you can't see it well here, but if you look at all this sideband distortion going up here, if you look at that book that I sent you a link to, if you ever get a chance to buy it, it's just a couple bucks to give you a really good understanding about distortion that's happening. What's happening that, well, I've been talking to the author, and he's going to start putting some of this in there because we hadn't discussed it, and it's really pertinent in the stuff that we were discussing, or he was discussing in the book. So he's getting ready to, I think he's going to get ready to rewrite it after I sent this information to him, because what's happening is this starts getting aliased back. So what's happening, if you look at this right here, you can't see it because of the wide band of it, but it's aliasing. What it's happening is it's going up and then bouncing back in there. It's aliasing back into lower frequencies, and on top of it, harmonic intermodulation distortion on top of the aliasing. And the problem is, on top of that, is it's inclusive and it's repetitive. So what happens is it goes up, aliases, intermodulates, aliases, intermodulates, aliases, intermodulates, and now you have a noise floor, a white noise, pink noise, or God knows what's going on down there, that is affecting every frequency that you have and causing sideband distortion. So basically, you got a never-ending mess that goes into it. You can't, in an infinite integral, when you're looking at a fast Fourier transform instead of a discrete Fourier transform, it's infinite rather than finite. So the problem is it's infinite. It doesn't ever end. So, you know, and the more you push up the volume, and today you want to compact it way up there, you've just caused an infinite flow of intermodulation, distortion, and aliasing into the system that it's being played through or into the studio. And it's a mess. You know what I'm saying? So you may not hear it that way, but if you hear it without it, you would know in a second. You'd just be like, wow, dude, who just took the huge distortion pedal off my symphony or off my tune? I can hear everything crystal clear now. What happened? Intermodulation distortion, the aliasing gone. But it's such a difficult concept. Also, check this out. If you do this, watch when I bring this lower frequency up. Watch this sideband distortion here, and this will freak you out, and this is an audio engineer's nightmare. Watch what happens. Do you see it separating and the wide sideband distortion getting huge, huh? So now you're seeing what happens when the mid or the upper low mid frequencies start mixing with the upper frequencies. What's happening? Now you see the sideband distortion just got to be a mess. So when you see all that compact shit up in your upper end, that's a goddamn audio engineer's mess, you know, a nightmare. But you think it's like total equality. Well, it's not. It's a goddamn mess. And if you could get rid of it, it would sure help. You would hear that it just, all that stuff you start out with, you're trying to make all that crap sound good with all your processors, in which multiply it and make it worse. You know what I'm saying? So watch this up here. You see this up here in the sideband frequencies. Watch when I get closer. Okay, check this out. Here's the nightmare. You see these sideband frequencies here, 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 and here, and all the shit around it? That right there is the frequency that you want the individual to hurt here, right? That's that A note that flute's playing way up there, or whatever, that's a harmonic quality of some tonal timbre that you want in your production because it's part of the beautiful timbre of some instrument or some mixture of timbres. Does that make sense in a symphonic sense? Well, all the other crap is 10 times louder than the note you want them to hear. And it gets worse and worse and worse. So as you mix all that together, you've got an entire fucking range of what looks like noise floor crap that's louder than the shit you want the people to hear. And this is just using 2 sine waves. So you got some understanding that it's a mess. and the processing that they do aren't dealing with the issues. And so it's something I've been working on, but I've got a mathematical laboratory like MATLAB, but it's going to take some work to work it out, because it's got to flow with the instrument to maintain the harmonic character and to separate them from the other harmonic characters, so that when it sums into a time domain frequency instead of a spectrum domain view, that waveform hasn't become completely distorted by the time frequency content. So but you understand that there's the frequency one here, there's the crap all over the damn place, and it doesn't affect the lower frequencies as bad, except for look at all this aliasing. You get tons of aliasing down lower frequencies, so when you're dealing with one instrument, you're good to go. You start, high pass or low pass filtering it to try to isolate it. But when you start mixing them together, and then you add some kind of nonlinearity, or try to warm it up, analog warmth, or whatever, or just the mixture of those timbres, all of a sudden you can't. You've got this other shit going on down here. You can't filter that out. It's going to either boost those signals or cause sideband distortion of all that, which causes a complete fucking mess that you don't notice. Or you've been doing it so long that it's become so normal that if all of a sudden it was gone, you would know it in 2 seconds. But since your ear's so used to hearing it, you think it's a tonal quality. Well, it's not, it's destroying the mix. And, in some ways it's good, in some ways it's bad, but you understand. That's what I've been dealing with. Anyway, peace, love, dude. Hope you enjoyed the vid, and you kind of understand that.